Hi everybody, this is just a short video to explain mutual inductance. So the word mutual stands for two and it involves two coils, and let's say there are two coils here. One of them has got a source of power, so if I turn that on there's going to be a current, and what you know is whenever there's a current flowing through a coil, it's a magnetic field around it. These are called lines of flux. Now, if I have another coil close to it, you see some of these lines of flux are passing through this coil as well. If it's very far away, there's not much of an effect. I'm just going to stop the current and I'm going to bring this quite close. If I bring it closer, you can see that more of the lines of flux are going to pass through it, right? Okay, so it's called the lines of flux from one coil is linking the lines of flux of the other. But you see this lamp is not glowing. There's nothing happening because this is a steady current. Watch what happens if I keep changing the current by just clicking this knob back and forth. So can you see that? So what's happening is when there's a change in current, there's a change in flux. And when there's a change in flux that is linking the loops of the second one, there's a voltage that's induced in the second coil. And this is what we call mutual inductance. Okay, and the letter for this is M, and this is the principle on which the transformer works. So the word transform means to change. So it's possible to change your input voltage to a different output voltage. And what I can do with this is reduce the number of loops. And watch what happens if I reduce the number of loops. Not that much. Okay. If I increase the number of loops, that's as much as I can get. Nothing happens if I don't change the current. The whole thing is you need to change the current, and it becomes quite cumbersome to keep moving this back and forth. So what we actually use for this to work properly is an alternating current, which is actually changing direction the whole time. So that's the principle for mutual inductance. And if I swap this for an alternating current, see what happens. Okay, so can increase the frequency, and there's always an induced voltage. Okay, and that's what this lesson is about. So bye for now.